Okay, so this is a video about the product rule, which is a product rule for derivatives. And you'll see it written kind of multiple ways. If you have, so the reason it's called the product rule is because if your function, which we'll call h, is the product of two other functions, then the derivative is one of the functions times the derivative of the other plus the derivative of the first one times the other one. If you have h is f times g times r, then the derivative is f prime times g times r, random parentheses, plus f g prime r plus f g r prime. But in particular, we're going to focus here when we have two. And you can actually sort of use this one to prove this one, and then so on and so forth, where each time you take the whole product, take the derivative of one at a time and make, this one f, then g, then r. If there were four of them, then you'd have one more where you take the derivative of the last one and so forth. Because I think at the moment you guys have only had the pretty much polynomials. I know you're maybe memorizing some of the trig ones, but it's a little bit handy, I guess, so let's pretend that it was just polynomials. Okay, so I'm going to use some very basic polynomials to just try to prove to you that the thing does what it's supposed to do, and then I'm going to tell you the formula that I prefer to the h of x, f of x, g of x business. Okay, well, kind of using up all my letters here. So if I first just FOIL this, then I will get as x to the m plus t plus bs x to the n plus t plus ak x to the m plus w plus bk x to the n plus w. So the derivative is a times s times m plus t x to the m plus t minus 1 plus oh darn. Let's start writing smaller right there. Okay, so remember that that's a t and that's a minus 1. Now, put that down a minute. Guess I could have planned this better. So now I I'm going to use the product rule. Okay. So if I take the derivative of the first, that's nothing. So ma x to the m minus 1 plus bn x to the n minus 1 times the second guy plus, now the derivative of the second guy times the first guy. And now I'm going to FOIL on top and bottom, so I get MAS x to the m minus 1 plus t plus BNS x to the n minus 1 plus t plus MAK x to the m minus 1 plus w plus BNK x to the n minus 1 plus w plus, so that's the first line, STA x to the t minus 1 plus m plus STB times x. Sorry, my computer notified me of something, so I have to delete that little bit. STB x to the t minus 1 plus n plus WAK x to the w minus 1 plus m plus BWK x to the w minus 1 plus m. Plus n. Okay, so note that these two are both of the m plus t minus 1 form, right here. I can factor out the AS, and I'll get m plus t. So AS, m plus t for that power of x. These two are both n plus t minus 1, so that's this one. If I factor out BS, I get n plus t, BS, n plus t. Then these are the m plus w minus 1, m plus w minus 1. I factor out the AK, and I get m plus w, AK, m plus w. And over here, this is the n plus w minus 1. And I factor out the BK, and I have n plus w, BK, n plus w. So that is a proof that you hate, but maybe that some of you would like to see that this thing actually kind of works. And in the case of two little binomials, it would actually be easier just to multiply them and take the derivative that way, but that's not always the case, and as we often do in math, we do one thing in a way that would be easier to do a different way, just to teach you a tool, a method. So if you have, so let me first say, if you had, say, that. I would not call these like g of x and h of x. I call them u and v. And then because this is a function in one variable, and you're in one variable calculus anyway, so it's always going to have one variable, well, for the most part, you can just say f prime and not have to say of x, right? So usually I make this y equals u times v, so that instead of f prime of x equals g prime of x times h of x plus g of x times h prime x, I can just say y equals u prime v plus v prime u. It's easier for me to remember. It's cleaner to write, and also later when you have the quotient rule, this will be easier to remember, and doing it in this order will help you. But as far as the product rule, you could do it in either order, but I don't suggest it. So I make a little chart. U is 3x squared plus 7. V is, I'll usually write that, but I don't have much room. U prime is 6x. V prime is 45x to the fourth minus 2. And then f prime, or y prime, is u prime v plus v prime u is 6x times 9x squared minus 2x plus 2 plus 45x to the fourth minus 2 times 3x squared plus 7. And then you distribute that one, so 54x cubed minus 12x squared plus 12x plus, and now you have to FOIL this one, 135x to the sixth minus 6x squared plus 7 times 45, 315 maybe? X to the fourth minus 14. My computer keeps notifying me of garbage and I have to come back. Okay, so then you combine like terms, so you would combine the x squareds. That's the only thing that shows up more than once, and you'd rewrite it. Now, again, with polynomials, this might not always be the fastest, but you still need to know how to do it. It also leads to another rule or two that you're going to definitely want to have. But also, so the derivative of sine with respect to x is cosine. So if you had, say, y equals 3x squared plus 7 times cosine x, if you distribute that, you don't know how to take the derivative of 3x squared cosine x unless you use the product rule. So in times like these, you kind of have to have it. Oh, sorry. The derivative of cosine is negative sine. Okay, so then y prime, 6x cosine x plus negative sine x times 3x squared plus 7. You can't really clean that up, so you'd probably just, instead of plus a minus, you just write minus and then you'd call it done.